To remember the metric system ladder, all you have to remember is King Henry did nothing during class Monday. Now, when we draw a ladder, it has to have 7 steps. The K at the beginning is for King, the H is for Henry, did, and then nothing would be here during class Monday. So we're using the beginning of each word to draw our ladder accurately. The only one we don't use is the word nothing means we put nothing in this circle. Now, when we go down the ladder, we're actually multiplying by 10, but when we go up the ladder, we're dividing by 10. So the reason that middle section is left blank is because we need to read the problem first to figure out if we're going to be dealing with length, which is measured in meters, if we're dealing with capacity or liquids, which are measured in liters, or if we're dealing with grams, which are used for weight. Now, this is where we would start by drawing. Before I even start solving, I'm going to start by drawing my ladder. 1, 2, 3, 4, 5, 6, 7. 7 steps. And I'm going to use the beginning of each word. King Henry did nothing. I leave that part blank. During class Monday. Now I'm ready to solve, to read the problem and figure out what I'm dealing with. So it says, Isabel's drink has 31 grams, so I know I'm working with weight because grams are for weight, of sugar. How many kilograms of sugar does her drink contain? So I know that I'm going from 31 grams to how many kilograms. Now, here's when I can go ahead and fill in this blank area, the nothing, with a G because I know I'm working with grams. And I'm going to put a G for grams like kilograms, hectograms at the end of each letter, each step. Now, I'm going to take my 31. Okay, and I know that I'm dealing with grams, so this is where I'm starting. And I'm going to go to kilograms, so I'm moving up the ladder. How many times? 1, 2, 3 times. 3 times. So, because I'm going up the ladder, I must remember that that means I'm dividing. Okay, so I'm taking my 31 grams divided by 10 to the third power. Now, this is where exponents come in, or multiplying and dividing by the powers of 10, which we did in class a couple months ago during quarter 2. Now, I need to remember that when I'm thinking about a place value table, okay, for example, here's my decimal point. To the right, I have my tenths. After the tenths come my hundredths, and then my thousandths. Now, to the left of that decimal, I have my ones, then my tens, then my hundreds, then my thousands, and so on. So when I multiply, my number is always going to go to the left because multiplication makes a number get bigger. Okay, so multiplication makes a number go left. That means that division makes a number go smaller, so it moves to the right. Well, we need to remember that our decimal is actually going to do the opposite of that. Okay, so now we can start solving. So I'm going to take my 31 again. And because I don't have a decimal here, I only have a whole number, I need to remember that anytime I'm working with a whole number, my decimal goes to the right of it. Now, since I'm dividing, that means my number's moving to the right because it's getting smaller. So that means my decimal's going to move to the left 3 times. 1, 2, 3. My decimal's now here, and any blank space I just put in a 0. This means that 31 grams is the same as 31,000 kilograms. There's my answer. Let's look at another example. This one says, a recipe calls for 200 milliliters of lime juice. How many liters of lime juice does it call for? Now let's remember that I start with my ladder, so I need 7 steps. 1, 2, 3, 4, 5, 6, 7. And I say, King Henry did nothing during class Monday. Now, I know that I'm working with liters because of the L right here, which means I'm working with capacity or liquids. So that means that my L for liters will go here, as well as putting the L at the end of every single one of these, like milliliters, capital, deciliters, centiliters. So I put my L down for each step, and then I can solve. So I know that I'm starting with 200 milliliters, and I'm trying to figure out how many liters that would be. So I'm starting with milliliters, which is right here, and I'm going to move up to liters. That will be 1, 2, 3 times. So that means I'm taking 200, and since I'm moving up, I'm dividing by 10 to the third power. Again, when I'm dividing, the number gets smaller, which means it moves to the right, so the decimal has to move in the opposite direction, which is left. So I take my 200, and because it's a whole number, I know that my decimal goes here. I'm going to move it to the left 3 times because that's what my exponent tells me to do. 1, 2, 3. So now I could just say that 200 milliliters is the same as 2/10 of a liter. Let's look at one final example, and this time we're going to multiply. So again, I'm going to start with my 7 steps. 1, 2, 3, 4, 5, 6, 7. I'm going to remember to write King Henry did nothing during class Monday. Now my problem reads, how many meters are equivalent to 64 kilometers? So I know that I'm starting with 64 kilometers. And I'm trying to figure out how many meters that would be. So since I'm working with meters, I can go ahead and put that in here. That just means I'm working with length. And I'm going to put that M at the end of every step as well. So this would be kilometers and millimeters. So I'm going from kilometers down to meters. I start here and I move down 1, 2, 3 steps. So I'm going to take 64, and I know that I'm multiplying because I'm moving down the ladder. So 64 times 10, and since I moved down 3 steps, that would be to the third power. Again, 64 is a whole number, which means my decimal would go to the right of it. Because we're multiplying, this means my number is getting larger, so it's moving towards the left if we think about that place value table. My number, as it gets bigger, it moves to the left. So that means that my decimal has to do the opposite. It needs to move to the right 3 times. 1, 2, 3. My decimal's now here, and every blank space I can fill it in with a 0. This means that 64 kilometers is equivalent to 64,000 meters.